Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see about fuzzy C-means algorithm. It is a type of clustering algorithm. It is mostly used when we want to categorize a data point in more than one category, into more than one groups. In most of the traditional clustering algorithm, like K-means algorithm or hierarchical clustering, what happens is one data point will be classified, will be categorized into one group only. We can't have one data point having a probability to belong to two different groups or three different groups. So in case of fuzzy C-means algorithm, what will happen is we would be able to classify, we would be able to categorize a data point into more than one group. That is why we would use fuzzy C-means algorithm. Why would we need to categorize one data point into multiple categories? For example, let's take a customer as an example. We can't categorize customers into strictly into a single group. That would be many traits showed by a particular customer. We should be able to group them into different categories based on those different traits, and it is possible when we use the fuzzy C-means algorithm. So let's get into the algorithm and then see what it is. So today in this video, what we will be going through is we will be going through, as you see on my screen, the introduction, like what is the fuzzy C-means algorithm, the types of clustering, like there are broadly two types: hard clustering, soft clustering. What are they? What are the examples? What are the different scenarios where they can be used? A simple example for fuzzy C-means algorithm, like what happens, how it works, and the steps that is involved in fuzzy C-means algorithm. If we want to implement this algorithm, like what happens in the backend, what are all the different steps involved in it, what is the maths involved in it, and we will be going through like when to use this algorithm and a summary about this particular topic today. And in the next session, we will be going through the implementation of fuzzy C-means algorithm using Python. So let's get into the topic and then see more about fuzzy C-means algorithm. So as you see in my screen, the fuzzy C-means algorithm, it is a type of clustering algorithm. So clustering algorithm has like a multiple types, like a K-means algorithm is a type, and there is a hierarchical clustering, like depending upon the approach we have different names, and now we have the fuzzy C-means algorithm. So each one of these algorithms have an objective, like they work based on an assumption or they produce an output in a certain way. There is some kind of a difference between them, which makes it good for certain scenarios and not so good for other scenarios. So we are going to go through the fuzzy C-means algorithm today and then see what are the various scenarios where it can be maybe better as compared to the other algorithms. And in case of fuzzy C-means algorithm, as I explained, one data point can belong to more than one cluster. So the output produced by this algorithm is probability based. We will have a probability for each data point to which group it might belong to, so that it becomes possible for us to classify or group certain data points which are like in between different clusters, to group them into both the clusters with different probabilities. So we can't like take them as part of only one cluster, but what we do is we take them as part of both the cluster with different probabilities. The fuzzy C-means algorithm has a better accuracy in most of the scenarios. It works extremely well in cases where the data points are overlapping. In most real life situations, what happens is the data points would be overlapping. There will not be a clear different clusters. There will be certainly like many data points which kind of overlaps between different clusters, and hence fuzzy C-means algorithm becomes a better option in most of the clustering scenarios. What are all the various use cases? So as I explained, like the customer segmentation or customer clustering is one of the examples. The other example is gene classification. Like we want to group different genes that is exhibiting a certain behavior together, or like whatever it could be. Like we want to classify the different genes into different set of groups. So in those cases, it is very useful for us to use the fuzzy C-means algorithm. It can also be used in case of images. Like it can be used in image quantization. So image quantization is a technique where the number of unit colors in the image has been reduced. So this technique is very useful in order to reduce the number of unit colors, and hence what happens is it becomes very much possible for us to compress the image to a greater extent. If you are working on image data, if you are working on image classification, so then this technique can help to hold all the critical information that is present in the image, reduce the number of unit colors that is being displayed in the image, and hence increase the chances of compressing the image. Moving on to the types of clustering algorithm. So what are all the various types of clustering algorithm? The two broad classes of clustering algorithm are hard clustering and soft clustering. So when I say hard clustering, it is like the k-means algorithm, like one data point will belong to one cluster only. So as you see on my screen, so here, so this is the output of a k-means algorithm. As we see, the groups are classified strictly into cluster A or cluster B. There can't be any in-between scenarios. So same is applicable for hierarchical clustering, where we would have a data point that would be present in only one cluster. It can't be part of like two different clusters or two different groups. So that is the hard clustering. A typical example is k-means algorithm. When I go to the soft clustering, what happens is the data point can be part of two different groups. So as you see here, there are some data points which are in between, which has a distinctive like the probabilities, like as you see here. So it has a probability of 70-30, which means that 70% it is like the probability is towards the red and 30% towards the green. So if you see here on the other way, it is 78% towards green and 22% towards red. So we have the probability for each of the data points, and hence it is possible for some data point to be considered as part of like multiple clusters with a probability attached to it. So we know what is the group that is most closest to that particular data point, what are all the various other groups that shows a similar behavior. So it becomes very easy for us to understand, okay, what are all the data points that strictly or that is close enough for towards a particular cluster center, and what are all the data points that are towards the outer portion or like in between two different clusters. So it helps in better understanding the data. The next one is a simple example to show how fuzzy c-means algorithm works. So in order to explain the fuzzy c-means algorithm, what we will do is we will take a simple one-dimensional data. Let's say we have weight of a few people, and depending upon the weight of those people, we want to classify them into child and adult. So as you see on my screen here, there are two different scenarios, like 1 and 2. One is the scenario where we use hard clustering to solve the problem. So in case of hard clustering, what happens is all these data points until here are classified as child, and any data point after this particular point here are classified as an adult. There is nothing in between. So in case of soft clustering, what happens is, as you see, there is a smoother line between the child and the adult. There is a transition. So it is not a vertical line like we don't strictly classify like any data point until here should be a child and anything over this should be an adult. There is a transition. So as you see, there is a smoother line which transition from a child to an adult, and hence all these points that is present here are child, anything over here are adult, and anything in between are color coded in gray points here. So they are neither they are not child or adult, like in between both of them. So this is an typical example of how it works. In a real life scenario, what would happen is our data point will be of higher dimension. So here we have only one dimension, we have weight. But in a lot of real life scenarios, what would happen is we will have multiple attributes, and then we need to use all those attributes, and then we need to come up with the different clusters. But basically, this is how the algorithm works. In case of hard clustering, the output will be something like this. In case of soft clustering, there will be a smoother line which transition from one cluster to the other cluster, and hence we will have a whole set of probability which shows values in between both of them. So if you consider a data point that is here, what would happen is if you draw a straight line and hit this curve here, and then get an equivalent value from here. So let's say 0 is the adult and 1 is child. What would happen is we will have a probability of 0.9, which is like 90% child for this particular data point. So if you take a point here, like this particular point here, if you draw a line here and then go hit the x-axis, so y-axis, what will happen is you will see a probability that is inclined towards adult. So there is a higher probability, like it will be like a 80% adult and 20% child. So that's how the solution would work. So Moving on to the next one, like what are all the various steps that is involved in this particular fuzzy k-means algorithm? What is the math behind it? So as you see on my screen, very similar to the k-means algorithm. First, what happens is we identify the number of clusters, and then we randomly select C cluster centers from the data point. So if you see like this, if you take this as a data point, like if we say like we want to come up with 3 different clusters, then what we do is we identify random cluster centers, 3 different random cluster centers. So we start with the random cluster centers, and then we refine, like we iterate through the algorithm, and what will happen is towards the end it will converge, and then we would be able to identify, come up with the real clusters. So next one is we calculate the cluster membership probability. So how do we calculate the membership probability? So we calculate the membership probability using this particular formula here. So where I is the data point and j is the cluster center. So dij is the distance between the ith data point to the jth cluster. Whereas the m that you see here, it is the fuzziness parameter. So in general, the m value would range somewhere between 1 and infinity, and this value, the fuzziness factor, actually is useful to identify like how much sharing of data point can be allowed between the clusters. So it is a critical input that defines like how many clusters a particular data point can belong to. And we do this, like we do the summation for k is equal to 1 to c, where c is the number of clusters that is present in the data point, and the mu ij becomes the cluster membership, like ith data point to which jth cluster it belongs to. So by this way, we would be able to identify for each data point what is the most closest cluster of the 3 or whatever the number of clusters that we have for the data point. The second one, what we do is after identifying, like we started with the random cluster centers and we assign the data points to the right clusters, and then what we do is we recalculate the cluster centers, very similar to what happened in the k-means algorithm. If you have any questions about the k-means algorithm, I will provide the link to the k-means algorithm tutorial in the description, so you can go through the algorithm and understand how it works. So in case of fuzzy k-means algorithm as well, after allocating the data point to the clusters, what we do is we identify the new cluster center. So this step, like this iteration, continues until the cluster centers don't change, the data point allocation to the cluster centers doesn't change. So then what happens is after identifying the new cluster center, what we do is, as I said, like we iterate, like we repeat the step 2 and 3 until it converges. Like how do we identify whether the values converges? We identify using this particular formula here. So where hi minus vj is the distance between the ith data point to the jth cluster. So what we do is we have, let's say we have 3 different clusters here. So we identify the distance between each of those data point to the cluster center that it belongs to. So when we take the summation of all these values, the value should be minimal. So if it is the smallest or most optimal, so then what it means is, it means that we have reached the best solution. So our objective is to ensure that the cluster centers are identified in such a manner that the distance between the data point and the cluster center, when we add up all those values, it is like the most minimal value, which means that our objective is to reduce this particular function here. So once we achieved that, so then it means that we have the most ideal cluster. So let's moving on to the next one, like what are all the various scenarios where like the fuzzy k-means algorithm can be used. It can be used in all the scenarios where there is an overlap between the data points. A typical example would be any data that are related to customer characteristics or customer profile information. So in those cases, there is not an unit categorization. We can't categorize a particular customer to one particular group only. Each human being have multiple traits. So depending upon those traits, they can be grouped into different categories as well. So anything that is related to customer data, mostly it should have overlapping data points, and hence the fuzzy k-means algorithm should be a better option. And the results get better with the beta value, lower beta value. When I say lower beta value, what it means is the difference between the subsequent iteration. So when we have like a kth iteration and k plus 1th iteration, the difference between both of them, so that is the beta value. If we lower the difference, like if we lower the threshold, then what it means is, it means that it will take a lot of time to converge. If we increase the difference, then what it means is between kth iteration and k plus 1th iteration, if it reduces, let's say, by 20%, then that is enough for the algorithm. So the algorithm would stop. If we have a lower beta value, it means that it needs to go through a lot of iterations to reach to a data point, to reach to a point where the difference between k and k plus 1th is very small. And the last one is the data point belongs to more than one cluster. So that is the objective, that is the main functionality of an fuzzy C-means algorithm. We use fuzzy C-means algorithm to classify or to categorize the data point into multiple groups. So that's about the fuzzy C-means algorithm. And in the next session, what I will be doing is I'll be going through an implementation of fuzzy C-means algorithm using Python. So we will be using the inbuilt package that is available in Python, and we will be going through the implementation. Also, we will be going through image quantization, where what we do is the number of unit colors that is present in the image, if it is too high, then it is very difficult to compress those images. So what we do is we use a fuzzy C-means algorithm to reduce the number of unit colors that is present in an image. So what it helps is, it helps to hold the information that is present in the image, but at the same time it reduces the number of unit colors. And hence what happens is, once the number of distinct or unit colors has been reduced, it becomes very easy to compress those images to a higher extent. So if you are working on image classification, then that will be a good technique for you to use. So that's it for today. I hope you have learned something new about the fuzzy C-means algorithm. You would have learned about like what is it, how is it different from K-means algorithm, what type of scenarios it can be used. If you like what I'm doing here, please give a thumbs up and subscribe to my channel. If you know someone who's trying to learn data science, please share this series with them. Apart from learning data science in 100 days, what I also do is I create a lot of data science related contents. I do write articles in Medium, go through those articles and provide you a support if you like what I'm doing. That's it for now. See you in the next session. Bye until then.